Number 2 on the 2026 AIME II. The figure below shows a grid of 10 squares in a row. Each square has a diagonal connecting its lower left vertex to its upper right vertex. A bug moves along the line segments from vertex to vertex, never traversing the same segment twice, and never moving from right to left along a horizontal or diagonal segment. Let n be the number of paths the bug can take from the lower left corner A to the upper right corner B. One such path from A to B is shown by the thick line segments in the figure. Find the square root of n. So, to solve this problem, we have to first think that to find from this to here, then we need to find what is from this to this point here. And the reason why is because we can't make let's call this A going from A to B, AN. Then we can't make this equation since, well, if you see here, this is AN minus 1, the point doesn't cross here. That is why we need another function where it starts from the bottom and ends at the bottom. So first, let's call this function going from the bottom to the bottom AN. And let's call this function going from the bottom to the top BN. Let's start with AN. This here is AN minus 1. It should end it here. Then there is exactly two ways. I'll color it. Two ways to go from this point here, let's call it A prime, to B, our destination. Therefore, it is AN equals 2AN minus 1. Plus, we have to think of the case where it goes from the bottom to the top. Then it is two cases to go from this point, A prime prime, to B. So, 2AN minus 1 plus BN. Now let's do the same thing for BN. Now, it starts from point A to point B. Now, BN. There's exactly just one way to go. If we go down, then it will become AN, since it's starting from this point, this red point here, and ending at this red point. If, like, for example, we went here like this, we can go here, and it would be a BN plus this one case. BN minus 1 plus this one case. However, if we go down here, then it will become a AN. Now going to AN. There's exactly 1 and 2 cases. So it's plus 2AN minus 1. Now, let's look at these two formulas. AN equals 2AN minus 1 plus BN minus 1. And BN equals BN minus 1 plus 2AN minus 1. Then the only thing we can see from these two equations is that AN equals BN, since they're both 2AN minus 1 plus BN minus 1. Therefore, AN equals 3AN minus 1. And BN equals 3AN minus 1. BN minus 1. Therefore, it is a geometric sequence. A1 is 1, 2, 3 cases, which means that A10 equals 3 to the 10th power cases. What we're required to find is square root of n, so 3 to the 10th power square root equals 3 to the 5th power, and this is equal to 243. So the answer is 243.